the quiz review. So the first couple, you're just doing the Pythagorean theorem. You want to get the exact answer, which means leave it as a radical reduced, and the decimal answer rounded to 2 spaces. So Pythagorean theorem never hurts to always start off by just writing a squared plus b squared equals c squared. Remember, if it helps you, go ahead and label A, B, C. C is always hypotenuse, the longest side. So in this case, we're going to do 4 squared plus 10 squared equals c squared. Sorry, it's supposed to be a c. Okay, 4 squared is 16, 10 squared is 100, so c squared equals 116. Well, if we take the square root of that, that's not our exact answer because it can be reduced. And we looked at the green strip on our desk and just try numbers. You know, 100 is obviously not going to work. 81 won't work. You just work back. And when you do that, you will find out that 116 breaks down to 4 and 29. The 4 simplifies to 2. Square root of 4 is 2. Radical 29. And if you type the square root of 116 in the calculator, you will get 10.77 rounded. Okay, number 2. Again, very important here to write this first. Because we do have C. We don't have A, but we do have B. And again, A and B are interchangeable. So, 11 squared is 121. 8 squared is 64. If you subtract 121 minus 64, you get 59. You take the square root of that, and the square root of 59 does not simplify. Nothing goes into it. Okay? 49, 36, 25, 16, 9, 4, none of them. So you just leave it like that. And as a decimal, it is 7.55. Square root of 59. Sorry, didn't read my own handwriting. It was close. It's actually 57. So square root of 57, which is 7.55 rounded. Okay. Do these 3 numbers form a right triangle? Well, longest side will always be C, so we're just going to plug them in and see what we get. So we're going to do 24 squared plus 32 squared equals 40 squared. And what we end up with is 1600 equals 1600. So our answer is yes. On this one, again, longest side will be C. So 16 squared plus 30 squared equals 35 squared. We're going to test that out. So 16 squared plus 30 squared is 1156. 35 squared is 1225. So these are not equal, therefore the answer is no. Now, just jumping ahead, what we're going to be doing here in 5 and 6, since c squared is larger, that would actually make an obtuse triangle. Just a little foreshadowing. So, write acute or obtuse. Let's try it out. Remember, biggest number, I love technology. Biggest number will be C. So, we're going to say 9 squared plus 12 squared. We're actually going to leave that blank and say 17 squared. When I do that, I end up with 225 and 289. My c squared is greater. Sorry, again, that should be a c. C squared is greater, not greater than or equal, that looks like. So c squared is greater, therefore it is obtuse. Remember, we always look at c squared. That's another nice little cheat board. If c squared is greater, it's obtuse. If c squared is smaller, it's acute. Just always look at c squared. So 15 squared plus 36 squared. Try to figure out what this is. 37 squared. This gives us 1,521. And this gives us 1,369. Well, 1,369 is less than 1,521. So my c squared is less than, which makes this acute. It's the first time I've seen sideways lines shoot out. Okay. So, what kind of triangle is this? It's not labeled, but, I'm sorry, this should have been on the paper. These should have had 90-degree marks on them. I apologize. But, since the bases are the same, this is an isosceles triangle, and these are both 45. You can write them in there. Same thing over here, 45. So this is a 45, 45, 90. Remember, our magic number is radical 2. Remember I said there's two different numbers, 45 and 90, a little way to remember it. So, when we're going from a leg to the hypotenuse, the longest side, think about, are we getting bigger or smaller? We're getting bigger, which means we're going to multiply by radical 2. And quite simply here, just 3 radical 2. That's it. Now number 8, we're going from the hypotenuse to a leg. We're going from the longest side to a smaller side. So we're going to divide by radical 2. So we can do a little bit of work there. 8 over radical 2, we cannot have that, so we need to rationalize. We're doing a great job with this. Remember, that leads to 8 radical 2 over just 2, which will simplify like so. So, x is 4 radical 2, both legs. All right. Now we have 30, 60, 90. I've done one of each here. One given the short side, and remember, it kind of helps to label. One given the long side, and one given the hypotenuse. Okay? So remember, since we have 3 different numbers here, our magic number is going to be radical 3. Now, number 9 is the easiest because we already have the short side. And everything starts at the short side. So going to the hypotenuse, we're going to multiply by 2. So x is simply 10. Going to the long side, we're going to multiply by our magic radical 3. So 5 radical 3. That's the easiest one of them. Now the long side, remember, we always want to go to the short side before going to the hypotenuse. So if we're going from long to short, we're dividing. It's smaller. And our magic number is radical 3. So we're going to do 6 divided by radical 3. We have to rationalize. 6 radical 3 over 3. That becomes 2. So our short side is 2 radical 3. And then, again, like we did before, we simply just double this. And again, just the outside number. Think about this. If this was 2x, we would double it and make it 4x. So you just multiply by the coefficient of the radical. Okay. So in this one, we're starting with the hypotenuse. So we always want to go to the short side. Remember, we're getting smaller, so we're going to divide. And from hypotenuse to short is divide by 2. So that's just going to give us a 6 here. So x is 6. And then going to the long side, we're getting bigger from short to long. So multiply by our magic ratio of radical 3. So 6 radical 3. All right. Find the length of a diagonal of a square, the side measuring 7. Nope. Nope. Let's try this again. Let's try going that way first. Beautiful. Not the best square, but have to do. So 7 all around, right? So try to find the measurement of a diagonal. So that's just going, again, from the short side of a 45, 45, 90 to the hypotenuse. So the length of the diagonal is just simply going to be 7 radical 2 inches. Now an equilateral triangle, do my best to draw an equilateral triangle all the way around, has an altitude of 9. That means it's forming a 90-degree angle. Well, if every angle in an equilateral is 60, the altitude cuts this into 30, giving me a 60 here. So the altitude is 9. This is my short side. My long side is right there, the altitude. So remember, going from long to short, we're getting smaller, we're going to divide by radical 3. Then we rationalize, and that gives me 9 radical 3 over 3. That simplifies right there. So that means this is 3 radical 3. I have 2 ways to go about this. I could say this is also 3 radical 3, and that means that side is 6 radical 3. Or if I want to go from the short side to the hypotenuse, I just double it, which is the same thing. So it's 6 radical 3 all around. And again, remember, if this was 6x plus 6x plus 6x, that would just be 18x. So 6 radical 3, 3 times, is simply 18 radical 3 units. And that's all of this.